Dear students, in this presentation, we'll see topological ordering. The problem statement is design, implement C/C program to obtain topological order of vertices in a given digraph. Directed graph. This is a graph given having 5 nodes. 1, 2, 3, 4, 5. Um, uh, the edges which is starting or originating from a node towards other is called out edge, outward edge. Okay, in this case, node 1 is having 1 outer edge, 0 inward edge. For 2, 0 inward and 1 outward. For 3, 2 inward, 2 outward. For 4, 1 inward, 1 outward. For 5, 2 inward edge and 0 outward edge. In case of topological order, first we have to see the independent node where it is not depending on any other. Like 1, it is not depending on any other node. 2, it is not depending on any other node. So either you can start from 1 or 2, anything is okay. When you are writing the program for this one, usually you will be using stack. At the top, the latest pushed element will be there at the top that you are going to remove. When you are writing the program, it follows some kind of sequence. Anyways, the first thing that you have to do is for the given graph. This is a graph given. For that, we have to represent that internally. This is the adjacency matrix. There are 5 nodes. This is the destination and this is source. A to A or 1 to 1, 1 to 2, 1 to 3, 1 to 4. This number indicates that edge. Like 1 to 2, no edge here. 1 to 3, there is edge. 1 to, then 2 to 3, there is edge. 2 to 3, and 3 to 4, 3 to 5 are edge. 3 to 4 and 3 to 5, 4 to 5 is also there. Okay. The next step is to find in degree. In degree is summation of this column. In degree of node 1 is 0. In degree of node 2 is 0. In degree of 3 is 2. In degree of 4 is 1. In degree of 5 is 2. Okay. So for that we have to iterate. Like for adding this one, no, this is a way. You have to repeat it for all the nodes, and like this index is 1 1, this is 2 1, this is 3 1, this is 4 1, 5 1. That means the first the row part varies. So 2 for loops required for I equal to 1 to n. N is here, it is 5. Then j 1 to 5. You will be summing. So initially that sum value is 0. Initially sum value is 0. The sum is that in degree value is sum plus the cost matrix, the adjacency matrix A, and as we can 1 1, 2 1, 3 1, 4 1, 5 1, only one is varying, other is proper. Okay, so we have to give this index j, and the other side it is I. J start from 1 to 5, 1 to 1, 2 1, 3 1, 4 1, 5 1. All this can be added. So when you add this, you will get 0. You have to push that into stack. 0 is the index number. The in degree which is 0, to which vertex that in degree is 0. 1 is having in degree 0. 2 is having in degree 0. No other, any other node. Okay. Then in the next step, you have to pop the topmost one. 2 is popped. So in our order, 2 will come. When you are solving this manually, 1 also correct. When you are doing this programmatically, 2 will be the first. Okay. After removing that 2 from the stack, again you have to update this table. That in degree table is there, right? That you have to update. Okay. Earlier, I will indicate that I will write that in degree table again. For 1 it is 0, For 2 is 0. For 3 is 2. For 4 it is 1. For 5 it is 2. This table you have to update. After removing this 2, you have to update this table. Whichever the vertex where this particular edge is there, inward edge is there, that you have to subtract it. 3 has inward edge from 2, 3 has inward edge from 1. Okay, in that we have removed 2, only 1 you have to subtract from 3. So that 2 becomes now 1. 2 becomes 1. Okay, now again you see that whenever that after updation integrity becomes 0, you have to push that into stack. Okay, right now nothing is there because the top of the stack is 1. Now I'm going to remove 1 from the stack. Again you have to update. This is 0, this is 0. Then there is a inward edge from 1 to 2. So this becomes now 0. Okay, as soon as that becomes 0, you have to push that into stack. The index of that is 3. 3 is pushed into the stack. Okay, so 1 gone, bottom of the stack is 3. Okay, so when you are taking the top of the stack, the 3 is at the top, so 3 will be removed. The node which is where the outward edge is there, that is originated from 3, are removed. 4 you have to update. 4 now becomes 0. 5 out of update because there is an edge from 3 to 5. 1 you have to subtract. 1 you have to subtract. In that earlier actually 2, sorry, 2, now it becomes 1. 2 becomes 1. 2, wait. Two becomes 1. So this particular edge, after removing this 3, no, the bottom of the stack is now 3. 3. 3 after that 4. 4 will go to stack. 4 is popped out. 4 is the thing. Again you have to update this table. The vertex where there is an edge from that popped off vertex, that 4, there is a inward to 5. So you have to subtract. That 1 now becomes 0. This you have to push that. After pushing, you have to remove it. So 5 is the thing. This is the order. When you are doing programmatically, this is the order that will be maintained. 2, 1, 3, 4, 5. When you are doing manually, 1, 2, 3, 4, 5 is also correct answer. Okay. Now, to find the inward degree, this is a code which I wrote earlier. J equal to 1 to n in degree, initialized to 0. For that column you are adding, I equal to 1 to n, in degrees, in degree plus a of I plus 1. So when you do like that, you will get this in degree. As you can see, 0 in degree for 1, 0 for 2, 2 for 3, there is a 1 for 4 and 5, there is 2 inward degree. After that, you have to push the vertex whose in degrees 0. Again you scan this one, the in degree of 0, you push that into stack. Push that into stack. That vertex you have to push. Initially, we are going to push 1 and 2. Only 2 things are there which are having in degree 0 are pushed. Whether this is not null, top, not null. Okay. Remove from that, remove that top, that 2 is removed. 2 is removed. After removing that 2 will be removed from the stack. I will be removing that by erasing. Okay, this is the stack content. You print that one. Print that. 2 is printed. As I explained earlier, whichever the vertex where there is an edge which is originated from 2, if so, you subtract it. Whenever in degree becomes 0, add that into stack. Now, in the stack, nothing is there to add, so 1 you are removing from the stack, 1 you have to remove from this also. Again, same process. Okay, 2, 1, then 3 will come, 4 will come, then 5. Same thing is explained here. Okay, for this particular graph, this is the initial in degree. Right now, after scanning this, vertex 1 and 2 are having in degree 0. At the top, 2 is there, 2 is removed. Okay, after removing 2, this is the stack content. So subtract, update the in degree table. by because there's edge from 2 to 3, so subtract it, that becomes 0, push that. Okay. uh, uh, if it becomes 0, then only push, so no change here. One is removed, one is added to the output. Then there is edge from 1 to 3, subtracted 0, that is pushed onto stack. Vertex 3 is pushed onto stack, 3 is popped out, 2 and 3 is the order. Then the edge from 3, there is edge from 3 to 4, so subtract 1, that 1 becomes 0, 4 is pushed onto stack, 4 is removed. When 4 is removed, the vertex from which this removed vertex, if there is a edge originated from this one to this, you have to subtract it. 1 now becomes 0. Okay, this is the thing, this is the order. Line the line, or the function for finding the integrity variable, then two-dimensional array, that adjacency matrix, then integrity table, then number of vertices. Okay, you will be passing degree and adjacency matrix. A adjacency matrix, n number of vertices, read the value, you can print it. Call topological order. Topological order. This is the complete program. The final answer will be 2, 1, 3, 4, 5. Thank you.